Okay, so in this second part of the lesson, I'm going to show you how to answer questions like what's in the third part of your assignment about how to simplify rational. So I have some problems here. Let's zoom in. And what we're going to do is we're going to simplify all of these expressions. And the way that you simplify expressions, there's a big idea here. The big idea for simplifying rational expressions is that you are going to factor the numerator and the denominator. Now we'll abbreviate denominator denom. So you're going to factor the numerator and denominator. That will be like step 1. And then step 2, you're going to divide out common factors. So let me explain this with an example that's more numbers that we're more used to seeing all the time. So let's say I have the number 10 over 8. And I want to reduce this fraction, which is what you're doing. You're going to be reducing rational expressions, but you're going to be reducing algebraic expressions. But if I take 10 over 8 and I factor the 10 into 5 times 2, and I factor the 8 into 4 times 2, then I can at this point go ahead and divide 2 divided by 2, because 2 divided by 2 equals 1. And so 5 divided by 4 times 1 is 5/4. So that's how we can reduce 10/8 to 5/4. So we're going to keep this same idea going with each of these problems. And along the way, I'm also going to review a couple of the factoring techniques you're going to need to remember to be able to do on these problems, because we've got several different techniques that are going to come up. And that's how the rest of your math career is going to be. Whenever you're doing problems and you have to factor, you are going to be expected to do any technique at any given time. So if I look at this first example, I have to reduce x squared minus 9 over x minus 3. And if you notice this part right here, x squared is a perfect square, 9 is a perfect square. Well, x squared minus 9 is a great example of a difference of squares. And a difference of squares is when you have a perfect square subtracting another perfect square. So if I have the formula a squared minus b squared, then there's a factoring pattern for that, and it always factors to a plus b times a minus b, where a is the square root of a squared and b is the square root of b squared. So for this problem, I would factor the numerator. The square root of x squared is x, and the square root of 9 is 3. And notice my factoring pattern has a plus for one binomial and a minus for the other. So x plus 3 times x minus 3. Then I'll carry the denominator over x minus 3. And I notice I have some common factors. And so x minus 3 is a common factor with x minus 3, so I can divide it out to get x plus 3. And a special note, you can only divide out if the operation that's happening between factors is multiplication. If there were a plus here, we wouldn't be able to divide out. So you can only divide out common factors like these whenever you only see multiplication right next to it. All right, let's try the next one. Just draw a little line here in case I need the space. Okay, so now I need to reduce y squared minus 5y minus 6 over y squared minus 1. Hey, look, y squared minus 1 is another difference of squares, abbreviate DOS. And so that means I can factor out the denominator. The square root of y squared is y. The square root of 1 is 1. So my denominator is going to be y plus 1 times y minus 1. But now I need to factor the numerator. Well, the numerator is a trinomial because there's 1, 2, 3 terms. So I'll go ahead and try to just divide it up into 2 binomials. The first number is 2 numbers that multiply to be y squared. So y times y is y squared. The second part is 2 numbers that multiply to be -6, and then I'm trying to find numbers that will add or subtract to be -5. So if I think of 2 times 3, well, let me try 2 and 3. 2 times 3 is 6. 2 and 3 will equal 5, but if I try to make them both negative, -3 times -2 is +6, and I need -6. I'm going to have to erase that. Let's try that again. Okay, 2 numbers that multiply to be 6. How about 6 and 1? They need to multiply or add to be a -5. So if I do -6 and +1, and I'm just checking, 1 times -6 is -6, and 1 plus -6 is -5. Okay, so now I've got the numerator factored. I have the denominator factored. Now I'm going to look to see if there's any common factors that I can divide out. I've got a y plus 1 on top, and y plus 1 on the bottom. I'll divide those out, and so my answer is going to be y minus 6 divided by y plus 1. Okay, now let's try this next one. Blow it up a little bit. There we go. Okay, so on this next one, you'll notice the numerator and denominator both have 4 terms. So when there are 4 terms and you need a factor, you need to think about factoring by grouping. So I'm going to group each pair, and I'm going to factor out the greatest common factor of each pair. So I'm just going to work on the numerator first, and then I'll come back and work on the denominator. So for the numerator, it looks like the greatest common factor of the first 2 terms is an x, and the greatest common factor of the second 2 terms is an a. So I'm going to factor an x out of the first 2 terms and a positive a out of the second 2 terms. I need my eraser. Forgot to write the plus again. Positive a out of the second 2 terms. Okay, so then whenever I factor an x out of the first 2 terms, I'm going to be left with x minus 3. And when I factor an a out of the second 2 terms, I'm left with an x minus 3. And it's really important that these 2 binomials match, because when I come over and I write my factorization of the numerator, one factor is going to be what was on the outside, the x plus a, and the other factor is what was on the inside, the x minus 3. So the numerator has been factored. Now let's do that with the denominator. So I'm going to group again. Let's see. The greatest common factor of the first 2 looks to be an x. The greatest common factor of the second 2 looks like they both have a 3, but you see how there's a negative in front of that 3? Factor out a -3. So I'll factor an x out of the first group, -3 out of the second group. So when I factor an x out of the first group, I'll be left with an x minus a. When I factor a -3 out of the second group, I'll be left with x minus a as well. And again, we see x minus a and x minus a, those are the same. So then when I go to factor, write my final factorization of the denominator, I'll have x minus 3 times x minus a. So I have the numerator factored, I have the denominator factored. All that's left to do is cancel out or divide out any common factors. The numerator has an x minus 3. The denominator has an x minus 3. So I can factor those out, and my final reduction is x plus a divided by x minus a. And although these look really similar, we can't go any further because one has a plus and the other has a minus. Okay, and now at this last problem, a minus, or number 4, a minus b over b minus a. These are really similar. It looks like they're common factors, but they're not yet because the numerator has a positive a, the denominator has a negative a. The numerator has a negative b, the denominator has a positive b. So they're opposites. So whenever that happens, they look so close that you could almost cancel them out. Try factoring out a negative 1. So if I factor a negative 1 out of, let's say, the bottom, so I'm going to carry my numerator over. The denominator, I'm going to factor out a negative 1. That will leave me with negative b plus a. And if I look at what's happening with the numerator and the numerator has a positive a, and a negative b. Denominator, negative b, positive a. Those are the same, so you can factor those out. So I'm left with, looks like there's nothing on the top, but if there's nothing, you'll need to always put a 1 there. 1 divided by that negative 1, and 1 divided by negative 1 is negative 1. Okay, so then finally our last example here, I have an x squared minus 25. Oh, it's another difference of squares, so I'm going to go right away and say that that is x plus 5 times x minus 5 over 5 minus x. And I look and I notice that x minus 5 looks almost identical to 5 minus x. So in the denominator, I'll factor out a negative 1. So factor out negative 1 in the denominator. I have a negative 5 plus x, which now makes it the same as the x minus 5 on the top. So I can divide those two out. And I'm left with x plus 5 divided by negative 1, which is okay to leave like that. But I can also divide that negative 1 into the top. And so x divided by negative 1 is negative x. 5 divided by negative 1, negative 5. Okay, so then when you guys go to Delta Math, you'll have some problems that are similar to the ones that we just did. So here we can work this example out together. X to the 4th plus 6x cubed over 8x. So in the numerator, I'm going to try to factor it. There's only 2 terms, so I'm going to look to see if there's a common factor to factor out. They both at least have 3 x's, so I can factor out an x cubed from the top over times x plus 6 over, let's see, 8x. And if I have x cubed in the top, that's really like x times x times x. And then the x plus 6 over the denominator 8x. And then I can divide out any common factors. Let's see, that 8 is being multiplied by the x. It's not being added, it's just being multiplied. So I can divide this x out with any of those x's. So it looks like it'll simplify to be x squared times x plus 6 over 8. So I'm going to go in here. Oh, I forgot I need to, and I'm going to type that in. I need to see what I need to type in here. Let's see. This will work. X squared. No, that's not going to work. Okay. X struggling with my keypad here. Okay. Let me go to the regular keyboard. X squared times x, make sure I'm not typing that as an exponent, times x plus 6 over 8. Type it in, submit my answer, and I'm correct. And then the next problem is similar to one of the examples. Oh, look, x squared minus 36. That is a difference of squares. So that's similar to the other problems that we worked out. And that should be what you need to get through this third section. So at this point, you can stop, work on this third section, and then come back for the last video, or you can just go on straight to the next video. It's totally up to you, but good luck. And if you have any questions, type them in the discussion board at the end of the lesson.